Okay, let's dive right into this. Welcome back to part 3 of our explainer series on binary aperiodicity. Today, we are unpacking turning universality and the physical symbol system. So here's the massive question we're tackling today. Can an aperiodic sequence of zeros and ones actually capture human intelligence? It's huge, right? We're dropping right into this deep philosophical tension, the friction between abstract computing theory and the grounded physical reality of how machines actually operate. It's a question that has literally haunted computer science from the very beginning. To wrap our heads around this, we really have to start with a foundational idea: Turing universality. Back in 1936, Alan Turing conceptualized computing by formalizing the external symbolic manipulations that humans do with a pen and paper. And he proved that a single machine manipulating external symbols can theoretically compute anything computable. Because a digital computer is Turing universal, this aperiodic sequence of zeros and ones can simulate any conceivable process that can be digitized, provided it has enough time and memory. This conceptual leap was an absolute game changer, perfectly captured by George Dyson. He noted that the stored program computer broke the distinction between numbers that mean things and numbers that do things. Just think about how revolutionary that is. Modern computing completely changed the game by combining data and instructions into the exact same binary medium. Symbols for values and symbols for operations were suddenly living right there inside the exact same architecture. Now, this was obviously a massive triumph for mathematics and engineering. But what happens when we take these highly abstract computational frameworks and try to apply them directly to the nature of human thought? Well, that leads us directly to the hypothesis of intelligence. Which brings us to the famous physical symbol system hypothesis. Alan Newell and Herbert A. Simon boldly stated, "A physical symbol system has the necessary and sufficient means for general intelligent action." The crucial point here is that this hypothesis implies human thinking is, at its very core, just a form of symbol manipulation. And following that logic, if human thought is just manipulating symbols, then machines manipulating symbols can achieve true general intelligence. You see these physical symbol systems all around us. Think about formal logic with its ands and ors and nots, or algebra using x and y as placeholders. Even chess is a perfect example. You've got physical pieces and entirely legal moves forming a closed, defined system. And a computer program does the exact same thing. It takes physical patterns, combines them into structures, and manipulates them to pump out entirely new expressions. So the big question, does this actually mean your brain is just a symbol manipulator? Let's play detective for a second. We need to shift away from the theoretical magic of AI and look down into the cold, hard, physical reality of your laptop. Like, what is actually happening inside the hardware when you type a command? To unpack this, we use Charles Sanders Peirce's semiotic bridge, which explains how human associative thought connects to hardware execution. He breaks it down into 3 phases. First, representations, the actual symbols we create. Second, representaments, the active links connecting a physical action to a meaning, like pressing a key on your keyboard. And third, material perceptible structures, the actual physical hardware doing the work. It's a system entirely designed to map human meaning onto a physical medium. And that leads us to this really fascinating concept known as OS alpha. Think of your own human symbolic cognition as a core operating system. We are the semiotic agents. We create the meaning. We then take this OS alpha and essentially project it outward onto unthinking silicon substrates through these formal symbol systems. And this brilliantly illustrates the massive divide between mind and machine. Human cognition, or our OS alpha, is messy, it's associative, and it's totally driven by meaning. But hardware execution inside the machine, that is rigid, deterministic, and made entirely of clocked voltage levels and semiconductor switch states. Text essentially acts as the universal deterministic interface, bridging our messy intuition with the unthinking execution of the hardware. Let's strip away the illusion entirely for a moment. Look at the hardware reality. There are no zeros and ones physically existing inside wires. There are absolutely no tiny, meaningful semantic symbols residing in memory arrays. The hardware strictly uses transient electrical charges and moving electrons. Computers don't process meaning. They process uninterpretable continuous current that merely approximates binary arithmetic. Any deviations, those are just hardware glitches, not logical discrepancies. This physical reality actually exposes a massive flaw in classic early AI paradigms, famously seen in systems like CYC and SOAR. They operated under a total myth. They mistakenly assumed that simply typing human symbols into a computer instantly translates into internal machine knowledge. They were conflating the shapes on a screen with the uninterpretable physical switch states operating silently inside the machine's architecture. Let's move to and see how this builds. Because of this stark divide between meaning and electricity, we arrive at the great AI debate. The idea that symbolic AI equals true general intelligence has faced massive pushback from both the scientific and philosophical communities. And honestly, the evidence against purely symbolic intelligence is incredibly compelling. Think about it. Human expertise relies heavily on unconscious bodily intuition, as Hubert Dreyfus pointed out, not just rigid step-by-step logic. We rely on embodied cognition. Our abstract skills literally depend on the physical body. Plus, we have the symbol grounding problem. A matrix of numbers inside a neural network inherently lacks recognizable meaning on its own. The human brain simply doesn't seem to operate with these discrete, ungrounded internal tokens. So what does this all mean? We arrive at our final provocative question. Are we simply projecting our own human OS alpha onto unthinking silicon switch states? Is artificial intelligence truly intelligent? Or is it just an incredibly elaborate mirror, reflecting back our own profound human capacity for making meaning? Well, that's something to think about. Thank you so much for joining me for this explainer. I really hope this helps you see the digital world a bit differently. Keep questioning and keep learning.